Alright, so today's date is Wednesday, December 11th. We are doing our practice final for Precalculus. It has 37 questions. That's everything we've ever done. I'm probably not going to get through the entire video today. Let's go through this. Resources, you get a calculator. So one of those guys. If you want to grab one now, I recommend it because you'll need it for question number 2. This is the part where y'all get up and get a calculator. Fiona knows what's going on. Anyway, problem number 1. In fact, do I have a... I'll have that up and ready to go. So, which expressions are equivalent to x to the power 3 plus 6x? So, I need to multiply all these together. I highly recommend multiplying these two first. You can either FOIL it or do a general rectangle. I find general rectangles to be easier, so let me zoom in here so I can see what's going on. So, you could do the outside first. It makes it a little, I mean, it's as easy, but this one is going to be a little bit easier to do first. So, if I go and I say x plus 3i and x minus 2i, that's going to be x squared. I have 3xi minus 2xi and minus 6i squared. I squared, Geo, is what?
-1.
Chris knows. I squared is -1, which means this is positive 6, because a -1 times a -6 is a positive 6. So if I add up all of that area, what I'm left with, and I can kind of write this underneath right now, this right here turns into, these two multiplied together, turns into x squared plus xi plus 6. And I still have that x that I need to multiply by and minus xi that I haven't dealt with. So after multiplying everything by x, this is now going to turn into x cubed plus x squared I plus 6x, and I still need to subtract xi. So if I subtract xi, notice that there are no more xi terms. The whole idea was we would be able to eliminate this x squared I to get x cubed plus 6x. That's a plus right there. But notice that this is an x squared I and this is a minus xi. Those two you cannot combine, which means that is not the answer. Again, the whole idea is I want to somehow subtract this x squared I to get to x to the power 3 plus 6x. So it's not A. Let's try part B. So part B is saying, oh, if I have plus the square root of 6 minus the square root of 6, if I don't have any imaginary part, if there's no I here, you are always going to have a difference of squares, which is going to be x squared minus whatever this thing is squared. Square root of 6 squared is 6. So these two boil down, x plus square root of 6, x minus square root of 6. That boils down into x squared minus 6, and then I need to multiply by x. When I do that, let's go ahead and write off to the side. When I multiply by the x, I get x to the power 3 minus 6x. And that's close. I'm off by this plus sign. I have a minus sign instead of a plus sign, so it's not B either. C is a correct answer, as Gio said.
How am I cheating?
Let's talk about why. The only difference between A and C is this x squared I versus the xi. Everything else is the same between A and C, which means if I'm rewriting this line, I'm basically copying and pasting this. This is now x cubed plus x squared I plus 6x, and then I have to subtract an x squared I. And you can see here, if I have an x squared I and I subtract an x squared I, those two terms cancel out. And I'm left with just x cubed plus 6x, x cubed plus 6x. That is an equivalent form. D, I think, is also an answer. But let's check. I'm not exactly sure. I did this kind of late last night. So again, I have to make another general rectangle, or you can call it your area model, however you prefer. So I have an x plus I square root of x, or I square root of 6, and then x minus I square root of 6. Filling in the box, x times x is x squared. This is x times I square root of x is x I square root of 6. You just squish them all together. This is negative xi square root of 6. And notice, before I even do the last one, these two terms cancel out. One was positive, one was negative. Finally, getting to the last one, I have negative times a positive is a negative. I times I is I squared.
And that's positive.
And that is a positive.
Six.
And
Wow,
square root of
there's
6
an
times square root of 6 is 6, which means the final answer is just, you can kind of ignore this I squared because negative I squared is 1. And that's 6. And then I need to multiply by x as well. So let's go ahead and rewrite what we have for the inside of the area. The area here is x squared plus 6. Both of these two expressions multiply together to get x squared plus 6. Then I still need to multiply by the x. And you can clearly see we are also going to get x cubed plus 6x. So D is also an answer.
Yes.
I am moving on to question number 2, where I will need a calculator. Question number 2 tells me I need to convert this from polar form. I have a modulus and an argument, and I need to convert that into rectangular form, and I'm going to be rounding. If it ever says round to the nearest thousandth, that means you're probably using a calculator. In fact, yeah, that's the hint I'll give you. If it says round, you're using a calculator. This is the one that you just need to know in order to find this real number. It's going to be your modulus. So I'm going to say the general formula is your modulus times cosine of your argument. And to find the imaginary part, the imaginary component, it's again your modulus times, not cosine, but sine of your argument. And we know what our argument is, so I can come down here and say, okay, well, the absolute value of z, the modulus here is 3, and then the argument we also know is 20, so 3 times cosine of 20. I just need to punch that into my calculator. Done. That's the answer. It's rounding correctly to the nearest thousandth, which means 3 decimal places. And I need to do the same thing for 3 times sine of 20. And I'm in degrees. I'm not in radians. I don't have to worry about that, so I just pull up my calculator. And I say, okay, let's find the cosine of 20. So 20 cosine. You do it a little bit differently on yours. Here's cosine of 20. I think I'm in degrees here. And then I multiply that by 3. And I get 2.819, again rounding to the nearest thousandth, which is 3 decimal places. So 2.819, I can write down 2.819. 2.819, and I kind of do the same thing. I take sine of 20. On your calculators, you actually type in 3 times sine of 20. On my calculator, it's a little bit harder. I have to first go, okay, I have to do 20, then I type in sine, and then I multiply that by 3. And I get 1.026.
I got 2.81.
1.026. And that is number 2. Check that you know how to use your calculators. You're ready to go. Again, it's going to be the same type of question. They might be shuffled. For like the first 10 questions, number 2 might not be this exact same formula. It might be somewhere else, but you are going to be using this formula maybe somewhere. The other possibility is I might throw in a special right triangle. You can look at the wall. The wall is your open textbook, right? Again, while you're working on these problems, if you do not remember these formulas, write them down on your note card, which is your giant 8.5 by 11 sheet of paper for the final. You have a note card for the final. Go ahead and write that down. We're on to number 3. I need to, again, convert this polar form into rectangular form. This is going to be using special right triangles, but in this case, it's even easier. So when every single time that you're converting between polar and rectangular form, graph it. That's my major hint. Graph it. If you can point to 270, it helps. Everyone, right now, point to 270 unless you're Eva who's working on other things. Where's 270?
Somewhere around here, actually.
270 is right there. Straight down. Again, as a review, and you can have this on your note card as well, you can go back through your notes. You can say, okay, that's 0 degrees, that's 90 degrees, that's 180 degrees, that's 270 degrees. You can do that in radians again if you want. 0 radians, pi over 2 radians, pi radians, or 3 pi over 2 radians. Those are the kind of big ones that you really, really should know. You should also know, like, oh yeah, 2 pi over 3, that's right there. You should know all those other ones as well. Anyway, since we're going to 270, the modulus here is 10. That means I'm going a distance of 10 straight down. So this distance right here is 10. If I go 10 straight down on this complex plane, again, you think of up and down. If I come down here, I can make a new plane. up and down, that's imaginary, negative imaginary. That's a positive 1. This is a positive imaginary, and a negative 1. Which means if I go straight down, it's a purely negative number. The correct answer here is just negative 10i. It's a purely imaginary number. If I go straight down on the complex plane, this is the complex plane here that I'm talking about. If I came to right here, I'd go minus some amount in the real, minus some amount in the imaginary. This would be minus some amount in the real, plus some amount in the imaginary. I'm purely imaginary because I'm on the axis. It's nice and easy. Again, you might need to use a special right triangle on the final. Know how to use those. Special right triangles. Those posters up there in the top left of the cabinets. Number 4. I need to find the average of these two complex numbers. So I'm going to find the average of the reals. It's going to be the average of the reals plus the average, I can spell here, the average of the imaginaries. So let's talk about the reals. The reals, 14 and negative 6. To find the average, you add them and divide by however many there were, in this case 2. So I say, okay, for the reals, I guess I'm technically finding the average of the reals. I'm saying 14 plus this negative 6. I add the two numbers and then divide by 2. So 14 minus 6 is 8, and 8 divided by 2 is 4. So I have my first component, 4. Notice that there is not a comma. There is no comma. Instead, I'm going to be adding because you're just doing the real component plus the imaginary component. So the average, I can do this in a different color to make it pop out more. The average for the imaginary components, again, I add them and then divide by 2. So 6i plus 6i. Well, it's pretty easy to tell. What is the average of 6i and 6i? 6i. If everyone has a 3, what's the average? It's a 3. Again, you can do it the long way, which is add them both together, divide by 2. You get 12i divided by 2, which is, again, 6i. You could have just told from the right beginning, though. And that's the final answer. That's it. Number 4. Moving on to number 5. Identify the real component and the imaginary component. Again, the imaginary component is the thing that's attached to the I. That's not I. The imaginary component does not include I. The imaginary component is just 4.1. The real component is 85. Done. If there are negatives, include the negatives in here as well. Do not put the I. I will write that in all red, all caps.
I'm sorry.
Do not
I'm sorry, Jesus.
put
Why my paper?
the I.
What is that thing dangling on the projector? Is that like...
That's the Raspberry Pi that I'm setting up for Jaden, for the TV that's going to be out there. You guys are all clear on what's happening with that?
Yes. Yeah.
It's going to be like announcements that scroll through.
Isn't that cool?
Yeah, it's cool.
See what James did for our school?
Yeah, it's pretty nice. I mean, I helped him a little bit, but it was his idea.
You can't
He's
get
like,
credit.
I
I helped.
Dude, his
I would like to be
class
acknowledged
year,
under... Jaden is the main dude that did everything, though. I will go and say that again. Jaden is the main person that did that. I definitely supported him. All right, so this one is the hardest type of question on this category. So we have the 3 categories. We have the polar and rectangular form. In this category, this is the hardest type of problem because I need to convert from this rectangular form into polar form. Then I take it to the power of 2 and then convert it back into rectangular form. Actually, it doesn't say that I need to be in rectangular form. I'm going to assume that needs to be in rectangular form. So, step number 1, convert to polar form.
God, give me space.
all that.
You're the one who's like this. This is not... This is...
In order to convert to polar form, again, it's the same hint that I'm going to give you over and over again. Graph it. Make a picture. If I graph this thing, negative 5 and then positive 5, I'm going to be right here. I can tell what angle I am because this is the same amount. The same amount. Obviously, one is negative, one is positive.
I'm gonna go write this.
And here is my angle. My angle is right here. That is 135 degrees. It doesn't really matter that it's 135 degrees. It does matter that this right here is a special right triangle. Is it at 45, 45, 90 or 30, 60, 90? What would you guys say?
45, 90.
It is indeed a 45, 45, 90. And I know that this real component right here is negative 5 square root of 2 over 2. Negative 5 square root of 2 over 2. And I know that the imaginary component is 5 square root of 2 over 2, that's positive. And if I know my rules of 45, 45, 90s, if I come down here and I say, how do I get from this leg to the hypotenuse? What operation, in other words, do I have to do to get from the leg to the hypotenuse? Does anyone know it from memory? Multiply by?
Square root of 2.
Oh my gosh, you guys are amazing. Good job. Yes, multiply by square root of 2. If you forget, you have a living textbook up on the wall. If I multiply by square root of 2, I now have the hypotenuse.
Is that gonna be up there for your phone or no?
I'm going to leave it up there, yeah. So I have 5 square root of 2 over 2. That was the original number, and I'm going to multiply that by, I can say just a dot, times the square root of 2, which is the same thing as saying square root of 2 over 1, right? If I multiply those, I get the square root of 2 squared, which is the same thing as just 5 times 2, all over 2. And notice that when you have that, you can just cancel out the 2's, and hey, I know the hypotenuse is therefore equal to 5. We're still in step 1, which is converting to polar form. We know that the modulus, aka the length, is 5. So we can come down here and say, okay, the modulus, absolute value of z, the way of notating that, was 5. But we still need to find the argument, this theta. The argument is this angle right here, which I already said before. Another way of thinking of it is it's a 45 angle here, so it's 180 minus that 45 degree angle to get this angle right here that I'm searching for, which is 135 degrees. It's 180 degrees minus this angle right here. We know it's a special right triangle of 45 to get 135 degrees. Okay, we have found the modulus and the argument. We've basically converted it to polar form. That was step 1. Step number 2 now is apply the power.
How many steps are there?
2. Well, technically 3.
There's actually like 5.
I don't fit. I'm like the problems here and like apply the power.
It depends. So I didn't really state in the question whether or not you need to answer in rectangular form or polar form. So technically you can just leave it in polar form after step 2. But I'm going to do step 3 as well, just in case that is on the final. So apply the power. So the power means this modulus is going to be. So I'll write this down as a rule. You should know this rule. For the modulus, you're always going to take that to the power. For the argument, you're always going to do the power times the argument. So if I come back down here, I say, okay, well, the modulus was 5, so I'm going to do 5 squared, and that's going to be 25. Multiply the 135 by 2, that's 270. So 135, what's up, Chris? I don't have that type of charger. It's a USB-C, right? I don't have it, sorry. Oh, it's an iPhone? Oh, yeah. That's USB. Oh, USB-C is the same thing as iPhone? I did not know that. Oh, it's AirPods, and I've never had legit AirPods, so mine is USB-C. That's why I'm confused. All right, so 2 times the argument, 2 times 135 degrees is 270 degrees. So your final answer for step 2 could be, it's kind of complex, but you could write out your final answer as 25 times the quantity of cosine of 270 degrees plus I sine of 270 degrees. And that could be your answer. I mean, it didn't say leave it in polar form or leave it in rectangular form in the question. So this could be an answer. But the hidden step 3, which I might ask for on the final, is convert it to polar form or convert it to rectangular form.
Bro, there's way too many steps.
You have a note card for a reason.
Can we use that big one?
Yeah.
Like,
AKA rectangular form is A plus BI form. And that's super easy if I just graph it. Where is 270 degrees? Everyone point to it. Hey, you remembered. 270 is right here. Well, how far am I going to be going down? What's my modulus?
25.
25. This length here is the modulus of 25, which means my final answer is just
25i.
negative
Yeah.
25i.
Just call me a she.
You want to become Rose? No.
That was question number 6. I'm now moving on to question number 7.
Go back.
wait, go.
I'll pause here for a second.
Wait, how'd you use the... okay.
See, let's go to a hospital. You guys from the school have some mental problems.
All right, I'm moving on.
It all started with this one, that one, that one.
Question number 7 is pretty straightforward. We have to ask ourselves, does 14 have any perfect squares? It's just, it's the square root of 2 times the square root of 7. Neither of those are perfect squares, and those are both prime numbers. So I can't do anything. The correct answer is just the square root of 14, and then I on the outside. I will make that note important. This I on the outside.
Can you put it in front of the square root?
You can put it in front or behind. It doesn't matter, yeah.
It don't matter.
And again, yeah, it can be front or back. Done.
Can you not?
What if Mr. Sindel had asked you a different question? What if Mr. Sindel had asked you, what is the plus or minus the square root of negative 49? What would you have said then? The answer is plus or minus
7i.
7i. Good. And that's another problem. That's problem 7a. All right. Problem number 8. I have the complex number z1 right here. I want you guys to plot its complex conjugate. My hint for you for complex conjugate is reflect over real axis. That has another name. This is the graphically version. On a graph, that's what it means. Algebraically, algebraically, it just means it means take the imaginary component and multiply by negative 1. So let's reflect this point over the real axis. Are you guys ready? Drum roll, and boom, there it is. It's the same point.
Whoa. How do you do that?
Because this point was on the real axis, I can't reflect over anything. It's just the same point. But what if I had asked you this point right here? Its complex conjugate is where? I go down here to negative 4. Boom.
Wow, look at you guys going.
You come down there. This one goes to itself. All right. Because it's on the real axis.
But what? Don't you have to multiply by a negative?
The imaginary component you multiply by a negative. What's the imaginary component of that number? That number is 7 plus 0i. So multiply 0i by negative 1. Go.
Yeah.
0.
I got you.
All right. We're on to question number 9. This one is very straightforward, but make sure that it's written correctly. The imaginary component needs to be second.
Okay.
It's written first here to confuse you. So after I distribute the negative 4, I get negative 80i minus 40. But that's not in the right order. The right order is negative 40 minus
Whoops.
80i.
That's all you have to do?
That's it, done.
I'm getting this one right.
Hopefully, right?
I'll be putting to God.
Number 10. What type of number is 90.65i? No matter what you have, the answer is always at least going to be complex. Every single time, 100% of the time, you will always be circling or filling in the bubble for complex. But it also might be one of these two as well.
It's imaginary, right?
This one is also pure imaginary.
I don't care if you say it or not.
It's not there.
Yes.
The i's just there.
It is always complex, but maybe also something else. Number 11. I need to find the angle that this makes. So if I'm looking for the angle and I don't, this one doesn't have a special right triangle. So if no special right triangle, right, I'm just going to do triangle. Then you're going to do the following. This is not a special right triangle because I don't see like square root of 3, 2, 1, stuff like that. This is not a special right triangle. Then I'm going to do the following. You take the arc tangent of the y divided by, or sorry, the imaginary component divided by the real component.
Oh, great.
And
Don't forget. Oh, yeah. Never mind. We're not naming
Don't forget you too, man.
There's gonna be don't forget repeat.
it. Yeah.
if this is in quadrant, if in quadrant 2 or 3, depending on what you need to do, you might need to add or subtract 180 degrees or pi radians. It really, really depends. In this case, we might need to add or subtract pi because it says use radians.
Wait, how does the graph quadrants go?
1, 2, 3, IV for 4. So if you're in these left quadrants, you might need to add or subtract 180. If it's supposed to be there. So you ask yourself now, -2 minus 5i, where is that? So graph this. -2 minus 5i, what quadrant does that live in? It lives in quadrant 3. -2 minus 5i lives down here in quadrant 3. So you can circle, hey, maybe I should make my arrow come down and say, hey, it lives down here in quadrant 3, which means I am going to have to add or subtract 180, or sorry, add or subtract pi, because I'm in radians. So I pull up my calculator at the ready. I'm going to type in arctangent of -5 divided by -2. Let me write it down first. I'm now doing arctan of -5 divided by -2. And I'm going to round to the nearest thousandth, which means 3 decimal places.
Yeah, but
So 5 divided by 2 is the same thing as -5 divided by -2. And then you take the arctangent, and for mine I'm going to have to do second arctangent. You should get, oh, I need to be in radians. Oops, let's clear that again. So 5 divided by 2. Now that I'm in radians, make sure you are in radians.
How do I check that?
Top right mode, or top center area
It
mode.
says degrees on that little like.
Yeah, so you change the
How do I
mode.
switch?
Oh, yeah.
Let me see someone's calculator, or maybe I can just grab one on my own. In order to switch, everyone come up here to hit second. No, that's not right either. How do you switch? Turn this on.
Oh, yeah, it is second. You know what?
Where is the mode?
Oh my gosh. I just
Oh, everyone hit DRG. It's to the right of the second button. Hit DRG, and then switch over to radians.
Yeah, that's right.
Where's that?
All right, so
I got zero. I got negative.
once I take arctan of 2.5 when I'm in radians, I should get 1.19.
Did I say Sego? Change my calculator.
1.19, and it needs to round to 3 decimal places, so 190. You do need that 0. All right, now the question is, do I need to add or subtract pi?
Wait, I didn't get that.
So did you hit DRG and switch to radians?
Yeah.
Then did you do the arctan of 2.5?
I put tangent. How do I get arctangent?
Hit second tan.
Wait,
I got 68 points.
You are in degrees, you need to be in radians.
Ain't it?
so you didn't do it.
Oh my god.
Everyone help each other, you guys got this.
Wait, -5 over 2?
-5 over -2 are the same thing as 5 divided by 2. So right now, this is giving you quadrant 1. In order to get to quadrant 3, I can add pi, but then I'll be too big. If I add pi to a positive number, I'm going to be beyond pi. I need to be between negative pi and positive pi.
Syntax error?
I'll come help you guys in a sec.
It took me a while. I started pressing everything. That worked.
All right, so now that everyone got 1.190, we need to ask ourselves. We're obviously in the wrong quadrant because 1.190 is right about there. We need to rotate 180 degrees, or we need to add 180 degrees, add pi, or subtract pi. What do you guys think we're going to be doing?
It doesn't matter.
It does matter because of this domain now. If I add pi to an already positive number, I'm going to be bigger than pi, which means therefore I need to subtract pi. So I need to now subtract pi. So on my calculator, I come back here and I say, okay, I had that. Now just minus pi, and I get negative 1.951. Negative 1.951, and that is my final answer. I will give you this hint as well if you want to add it onto your note card.
No, I'm good. Just kidding, just kidding.
If you're supposed to be in quadrant 2, you are you're 100% of the time always going to be adding pi, or adding 180. If you need to be in quadrant 3, like we were, you need to subtract. 100% of the time that will work.
How do you know if you're subtracting, adding pi, or what?
If it tells you radians. If you're in radians, it's pi. If it's in degrees, it's 180. Yeah, and I can write that off to the side as well. This is for degrees. And this is for radians.
Wait, so the degrees.
And we were in radians, that's why we were adding or subtracting pi. All right, so I'm moving on to number 12. I need to find the distance between these complex numbers. If I think about this graphically, what I'm going to have is I'm going to have a point and a point. In order to find the distance of this diagonal, I need to make a right triangle and use Pythagorean theorem. Don't know why that happened.
Like, somewhere over there too.
So here we go. In order to go from 12 to 10, I need to go minus 2. In order to get from 12 to 10, I need to subtract 2. In order to get from positive 3 to negative 5, I need to subtract 8i. Again, going from Z1 to Z2, those are the two operations that I need to do, which means I need to go 2 left and 8 down.
And that's it.
2 left
Oh, that's not it.
and 8 down. Another way of thinking about it.
Wait, so you do Z2 minus Z1.
Yes, you can always, this is found by doing Z2 minus Z1. So if I'm making my right triangle,
Oh my god.
I'm going to go 2 left and 8 down. So 2 left and 8 down. And then I'm going to do Pythagorean theorem to figure out what this distance is. That is D. It says find that distance D. So I set it up. I say, okay, well I have negative 2 quantity squared, or you can just leave it as positive 2. It doesn't really matter. Plus that negative 8 quantity squared is equal to that D quantity squared. All right, and then just do the next step. 4 plus 64 is equal to D squared. And then this needs to be 68 is equal to D squared. Oop, that's not right. D squared. And therefore, D is equal to the square root of 68. But we're not done. You can simplify that radical.
Oh my god. How?
The square root of
68.
68 can be factored as the square root of 4 and the square root of 7. No, is 17, right?
Oh, it's not.
Let me check. 4 times 17 is 68. Good. Which means, if I factor it that way, this is now still the answer. Square root of 4 times square root of 17 is now 2 times the square root of 17.
Yes.
And that is our answer, D.
Oh.
When you get it wrong, if you still write the square root of 68.
You will get 3.5 out of 4. Moving on to number 13. We have finally hit that area. So we're done with the first section. The first section was just doing a polar and rectangular form. Now we've hit the review section, the review for AP Calculus. So this is a rational function. So, simplify this rational expression. What values of n make the expression undefined? Well, the things that make it undefined set this denominator equal to 0. I think the first thing that we should do first is just factoring. I said first too many times, but let's factor. On that bottom, I can factor out a negative 7, n. That is the greatest common factor. And then what's left over is a 2n plus 5. I factored the denominator. The numerator, I can factor a little bit, I guess, negative 7n times n. Why did you factor it that way, Mr. Sindel? Well, I saw negative 7n in the denominator, so I probably wanted negative 7n in the numerator to cancel them out.
Just like that, right?
Before we cancel it out, though, let's check which expression makes this undefined. Let's set this denominator equal to 0. So if I say negative 7n times 2n plus 5, is equal to 0. I use the zero product property and say, okay, well, that one and that one are going to make two equations. The first equation is negative 7n is equal to 0, and 2n plus 5 is equal to 0. That means n is equal to 0, or n is equal to negative 5 halves. 0 and 5 halves are the things that make it undefined. But that's not the full question. The full question is asking you to simplify the rational expression, which means we now can cancel out the things that are on the top and the bottom. I can cancel out that negative 7n, and I get the final answer over here of n. Oh, I can cancel out the n's as well.
Yeah.
Oh, wait, the n's already canceled out. Never mind. I thought there was another n that I can cancel out. So the final answer is just n divided by 2n plus 5.
Wait, that's not even the answer.
That is indeed the answer.
What? How?
Did you guys use it?
I canceled out the negative 7n on the top and on the bottom.
Wait,
Yeah,
how'd you
but
get 0?
that answer is not in the options right there.
So not only do you need to, so this is a two-part question.
I told you it was.
The first part is simplify, which we did. The second part is asking you which values make it undefined. That second part, the answers were C and D. There are two parts to that question. This question on the final will also have two parts. Moving on to number 14. Make sure that this is a fraction equal to a fraction.
It's getting long.
Not like this.
What time are we out of here at? We're out of here at 52. We got 3 more minutes. I'm going to cross multiply. 7 times 3k is 21k. Cross multiply the other direction. 1 times 5k minus 2 is just
What is that?
5k minus 2. From here, I'm going to solve. I can subtract 5k on both sides minus 5k. And I'm left with 16k is equal to negative 2. And from there, divide both sides by 16. And the answer is negative 1/8.
Yeah, I was reading the problem in the reverse section.
Moving on to the next question.
Can you play Risk tomorrow?
If you have this entire packet done, then sure. And all of your missing assignments in.
No, right.
Number 15. Subtract the following rational expressions. This guy is notoriously hard.
Oh, I know. Oh, trust.
The first step is to factor.
What's that?
Factor.
Factor. The numerator, I can't really do anything. X to the power 4. The bottom, the denominator of that left-hand fraction, I can factor. This is a difference of squares.
Oh.
3x plus 4
3x minus 4.
and 3x minus 4, the conjugate pair. Very good. On the right fraction, I can't simplify the numerator. I leave it as 7. The denominator, I can factor. I can factor out a 4 for the greatest common factor. And what's left over is a 3x minus 4. Hey, check that out. A 3x minus 4 on both the denominators for these fractions, which means I need to multiply by whatever is missing. Again, I need to make like denominators. So, what is missing from the left-hand side? I'm just missing this 4. There's no 4 down here, right? So if I multiply by 4, I have to multiply by the top as well, the numerator as well. Let me come back here and uncircle that. What is the right-hand side missing? I already have a 3x minus 4, 3x minus 4. I'm missing a 3x plus 4, so I'm going to multiply by 3x plus 4 and 3x plus 4. Do not multiply out the denominator. Leave it factored, which means I now have 4x to the power 4 minus 7 times the quantity of 3x plus 4. And the denominator is all of this stuff. This 4 times 3x plus 4 times 3x minus 4. I'm almost done. I just need to distribute that negative 7 and call it good.
Call it good now.
I'm allowed to subtract because I have like denominators. That's why I wrote it all over one fraction. And now my final answer, 4x to the power 4 minus 21x minus 28. All of this is going to be divided by that same denominator, 4 times the quantity of 3x plus 4 times the quantity of 3x minus 4. Your homework tonight is to review these first 15 questions, maybe do a little bit more if you want, and make up any missing assignments that you might have. We'll start on number 16 tomorrow for the warm-up.